Fabric Data Days. This is a 50-day skills test where you will have a chance to attend educational sessions, participate in hands-on contests and challenges, and also earn discount vouchers to get Fabric certified. So in this session, we'll translate your Power BI expertise into Fabric fluency from one lake and a direct lake to semantic models, pipelines, lake houses, warehouses, and also deployment. So you can pass DP-600 and deliver value in Fabric. If you're feeling confident with your Power BI skills and are ready to start working further up in the data stack and building solutions that scale, this session is for you. So let's get started. So we will start with exploring how Microsoft Fabric helps you grow for building reports in Power BI to building full analytics solutions as an analytics engineer. We will start with data preparation, the foundation, and in Power BI that usually means Power Query for a single data set. In Fabric, it expands to data factory pipelines, data flow Gen 2, and Spark notebooks for transforming and managing data across multiple sources in what is called a one lake in Fabric. Then we'll move on to semantic modeling, where familiar concepts like relationships and measures scale up. You will learn how enterprise data sets, direct lake mode, and governance let you build trusted and reusable data products instead of just one off models. And next, we will cover maintenance, keeping your solutions reliable. Fabric adds tools for monitoring capacities, managing workspaces, and automatic deployments with CI/CD, continuous integration and continuous deployment. Uh, this is where you shift from managing reports to managing analytics systems. Finally, we'll talk about DP-600 exam readiness and how to prepare through Microsoft Learn paths and hands-on labs and also other community resources. So by the end of this session, you will understand what it takes to move from your Power BI um, skills to Fabric Analytics Engineer and how the DP-600 helps you validate these skills. So we are going to quickly go discuss the certifications available to validate the skills of analysts using Fabric, and so you know which one is right for you. Even if you are not planning on getting certified, these skills are a great way to get a sense of how to distinguish the roles and what skills you might need to learn. Moving on, there. So today we are only looking at the analytics certificates. So feel free to mention DPs um, to decide if you don't want just analytics. There is also a data engineering certificate, which is the DP-700. So, but this session is specifically for Fabric Analytics Engineer certification. So there are two. So the audience here are expected to have PL-300 already. Even if you don't have, you can straight away sit the DP-600 exam. So moving on, and there is a link here, Fabric Career Hub. You can go there and explore the certifications. So the DP-600 exam is structured around three main skill areas, which together represent the full analytics engineering lifecycle in Fabric. Um, First, you'll need to maintain a data analytics solution that is and this is about reliability, governance, and process. In Power BI, you might manually refresh a data set and publish a report, but in Fabric, this scales up. You are implementing security and governance and managing workspace roles and data permissions and maintaining the analytics development lifecycle. So through version control and CI/CD pipelines and monitoring, you will achieve this. The focus here is keeping solutions sustainable and production ready. And the second thing that you are going to learn here is the biggest portion that you will have in the exam, and nearly half of it, 50%, which is the data preparation. So this is where you move beyond Power Query. You will work with data factory pipelines, data flow Gen 2, and Spark to ingest, transform, and enrich data at scale. So you'll also need to know how to query and analyze the data using SQL, KQL, and DAX, pulling together structured, semi-structured, and streaming sources into a unified view in one lake. And finally, you'll be tested on how to implement and manage semantic models. So this is where your Power BI skills really shine, but now applied at the enterprise levels. You will design and build models that multiple teams depend on, optimize them for direct lake and import performance, and also ensure they are governed, documented, and discoverable. So together, these areas reflect the evolution from being a Power BI report author to analytics engineer who can design, build, and maintain complete end-to-end solutions in Fabric. So the takeaway for you here is that DP-600 isn't about replacing what you know as part of PL-300, but it's about expanding the knowledge from building dashboards to building the foundation that makes those dashboards possible. And the DP-600 exam details are in this link below that is given. Moving on, so we will cover DP-600 skills in depth. So what does an analytics engineer do? So if you have taken or familiar with PL-300 or are working as an analyst using Power BI, using your Power BI skills, some of these skills areas are probably look familiar, like preparing data, building models, maintaining solutions. But in DP-600, you are doing all of those same things on a much broader and enterprise scale across Fabric workspaces, data pipelines, lakehouses, and warehouses, not just within your Power BI desktop. And here the first section, the maintain a data analytics solution, forms 25 to 30%. So in PL-300, maintenance means refreshing data sets and updating visuals, but in DP-600 it is about managing the whole life cycle, so implementing security and governance, handling workspace roles and permissions, and also automating deployments using CI/CD pipelines. So you are maintaining not just the reports but full analytics environments. And the next section is the prepare data, which is about 45 to 50%. And here, if you look at PL-300, it focuses on Power Query for shaping data in a single report, whereas DP-600 expands that to data factory pipelines, data flow Gen 2, and also Spark notebooks. So you will be pulling from data from multiple systems and storing it in one lake for reuse. That covers the get data part, and you will also use SQL, KQL, and DAX to query and analyze data. So the difference is you are moving from transforming for one data set to preparing data for the entire organization. So that covers the transform data part, and then you will be querying and analyzing data out of that transformed data. And the last section is implement and manage semantic models, which covers 25 to 30%. So in PL-300, you design a model for a report. In DP-600, you design semantic models that serve entire teams. Uh, um, and this results in optimizing the um, this results in optimizing with direct lake, tuning your for performance and governing access. So you're not just publishing models, but you are creating reusable, trusted data products that can be used in your entire organization. So while the categories are similar, it sounds similar. DP-600 shifts your focus from building reports to building and managing end-to-end analytics solutions that scale across the business. And here is the link to the DP-600 study guide. So moving on. Um, so this section is 4 slides, introduction to Microsoft Fabric. So we are starting here because we are going to jump to analytics engineering skills in Fabric. But we need to talk about Fabric first. So we are going to start with a bit of a level setting here. So we are going to introduce Fabric and talk about the different ways data is stored in Fabric before we jump into the first group of skills that an analytics engineer is responsible for, data prep, which is the data prep. So the here we have a overview of Fabric. Um, Fabric is nothing but unified data platform for the era of AI. So it's a scalable analytics platform, and it can be complex, fragmented, and expensive. Scalable analytics platform can be complex, fragmented, and expensive. So with Microsoft Fabric, you don't have to spend all your time combining various services from different vendors. What it does is you can use just a single product, which is Fabric, that is easy to understand, set up, create, and manage. So Fabric is a unified software as a service offering. And with all your data, one lake is where you store all your data in a single open format in one lake. So one lake is Fabric's lake centric architecture that provides a single integrated environment for data professionals and the business to collaborate on data projects. So think of it like one drive for data. So for tabular data, the analytics engines in Fabric will write data in delta format while writing to one lake. All engines will know how to read this format. That's why it's called open format, and treat delta files as tables no matter which engine writes it. So um, beneath the AI driven interface, driven assistance is the co-pilot. So one lake enjoys the unified data storage and is built on top of Azure Data Lake Storage, and data can be stored in any format, including Delta, Parquet, CSV, JSON, and more. And Purview is used for data governance and compliance. So if we look at this one, so OneLake is it's a Fabric is a unique unified data platform, SaaS product. You will get SaaS product experience and security and governance, compute and storage, and OneLake sits in the OneLake is the data storage part of it, and you have the data factory, data engineering, data warehouse, data science workloads, and real-time intelligence workloads, and Power BI workloads. Um, so what your one lake is the one copy in is a component, a key component of one lake that allows you to read data from a single copy without moving or duplicating data. And data storage in Fabric, everything revolves around one lake, a single unified data lake for your entire organization. And unlike Power BI, where your data typically sits in a data set or gets pulled from multiple silos, Fabric centralizes it. So all of your data whether structured, semi-structured, or unstructured, is stored once in one lake and can be accessed by any Fabric experience. On top of one lake, you have different storage experiences designed for different use cases. Lake houses, warehouses, and SQL databases. They all read and write data at the same to the same underlying storage, and but they are optimized for different roles and workflows. So let's start with the relational storage options in Fabric, which is uh, warehouse and SQL databases, Fabric SQL databases, and data warehouse Fabric warehouses. So these are similar if you have worked on with Power BI or SQL before. So after that, we'll explore lake houses, which is a concept that combines the flexibility of a data lake as well as a structure of a warehouse for scalable data preparation and transformation. So DP-600 mostly focuses on batch data. Streaming data in Fabric is called real-time intelligence workload, and we won't be going into that today. So let's move on. Um, so for structured relational data, Fabric gives you two main options, which is the Fabric warehouses and SQL databases. The warehouses provide a full T-SQL experience for just like your Azure SQL or Synapse. So if you have never used SQL before, think of it as a way to ask structured questions about your data. So you will have those filtering, joining, and summarizing tables at enterprise scale. And the SQL database is a smaller, lightweight workspace level option and it is perfect for prototypes, reference data, and also app specific use cases. Both read and write directly to into one lake. So whether you are working on a massive data model or a small project, you are always using the same unified data foundation. Now let's move on to lake houses in Fabric. So the lake house is a Fabric's answer to bridging data engineering and analytics. The lake house is a new territory for Power BI users, and it's where Fabric brings together the flexibility of a data lake with the structure of a warehouse. So it combines flexibility of a data lake with the structure of a data warehouse. Your data is stored in open formats like Delta Parquet, and you can work with it using Spark notebooks or SQL. For Power BI users, this is a big shift. Instead of pulling data into Power BI, you can build reusable semantic models, scalable data sets that live in the lakehouse and can be shared across teams. So think of it as your data prep and transformation zone. So where you get the data, clean, join, and shape data before you start modeling it. Moving on to prepare how to prepare data in Fabric. So this is a high level and is the bulk of skills of analytics engineer performs. So in Power BI, most of your prep happens in Power Query and the data model, often in a single report. Whereas in Fabric, you still do these same things, but at a larger scale. You are now preparing data once, so it can be reused by multiple teams and also multiple models and multiple reports. So today we'll break this into three steps: getting data, transforming data, and querying and analyzing data. This shows how um, each of these steps expand beyond the Power BI desktop. So if you go to the first step is the getting the data. So in Power BI, you probably used to connect to either Excel or SQL or other web sources. Fabric adds scale and flexibility. So you can ingest from lots of sources, batch or streaming into one lake. First, you ingest into one lake, whereas in Power BI, you ingest into Power BI, right? So tools like data factory pipelines um, lets you automate these data flows. So while data flows, Gen 2 and Spark notebooks let you prepare and transform data before it's modeled, data factory pipelines lets you automate these data flows. So the idea is one ingestion process feeds multiple reports and dashboards and your analytical products. So no more copy and paste or one off data sets. So that covers the get data part of it. And next step is the transform and explore data. So in Power BI, transformations happen in Power Query, usually just for one single data set, or unless you use data flow. In Fabric, transformations happen before the data reaches a report, and they are reusable by anyone in your organization. So you can do everything you already know: joins, filters, aggregations, but also leverage Spark notebooks for larger data sets and more complex scenarios. This allows you to centralize and govern transformations, so everyone is working from the same trusted data. So next one is get and transform data with data flow gen 2. So data flows gen 2 is familiar for Power BI users because it's like a Power Query but scaled for the organization. You can clean and shape data once, then reuse it across multiple reports or models. So everything is centralized and governed. And you can schedule refreshes or incremental loads. So your transformations are both reusable and production ready. So what sets them apart is that you can specify the data destination. See here, you have the in this screenshot you have a data destination, so you can set the data destination either to a lake house or a warehouse. Next comes orchestrate data with pipelines. So pipelines in Fabric lets you automate data movement and transformation at scale, so something that goes beyond the one-off Power BI refresh. So you can orchestrate multiple sources, schedule batch or streaming loads, and write directly into lakehouses, warehouses, or SQL databases. Now, pipelines will include monitoring and error handling. So your processes are production ready and reusable across teams. So building a foundation for enterprise analytics. So so here you have the key pipeline concepts, the activities and parameters. You can have parameters and pipeline runs. So pipelines are made up of activities, which are the individual steps that do tasks like copying data, running notebooks, or executing SQL queries. And parameters let you make the pipelines dynamic, so you can pass in values like file path or table names. Uh, so the same pipeline works for multiple data sets or environments. And every time a pipeline executes, it creates a pipeline run so that you can monitor that pipeline run. So and runs these pipeline runs let you track activity progress and monitor for success or failure, or troubleshoot issues. So together, these activities, parameters, and pipeline runs let you build automated, reusable, and production ready data workflows at an enterprise scale, which is far beyond that single Power BI refresh that you were doing in Power BI. So next comes data transformation and exploration with notebooks. So notebooks are a code first and interactive environment for preparing and exploring data, something completely new if you are coming from a Power BI perspective. So you can use multiple languages, Python, R, Spark, or SQL, depending on the type of data and the transformation you need. So think of notebooks as a playground for data engineering. So you can explore data sets, run experiments, test transformations, and combine different sources all in one place. So they are especially useful for um, they're especially useful for large data sets or complex calculations. Once you work in a notebook, once your work is ready in a notebook, the results can be stored in a lake house or a warehouse or a SQL database, making your transformation scalable, reusable, and governed across your organization. So, in short, notebooks let analytics engineers take full control of data prep at scale, combining coding flexibility with the enterprise level governance. And this becomes a step beyond anything available in traditional Power BI. So now that we have ingested and transformed our data, we have a clean, reusable data set ready for analysis. So in Power BI, analysis usually starts after the data set is imported into a report. Whereas in Fabric, we can query, explore, and validate data at scale before it reaches a semantic model. Um, and For this, we can use SQL, KQL, DAX, or notebooks. So the next section will show how analytics engineers take prepared data and turn it into insights that can be shared across the organization. So, which is the final step in data preparation. So, in Power BI, analysis is often inside the data set, which are the you can create the calculate columns and measures in DAX, and so on and so forth. Fabric expands this. You can query data before it reaches a data set. So, using either SQL for structured data, KQL for streaming and logs, and DAX for on semantic models. So, this gives you more flexibility to explore and validate data at scale, and test transformations, or prepare data for multiple downstream uses. So think of it as adding a query layer before the report, giving you more control and governance than you had in a single Power BI file. So the key takeaways are: if you are coming from Power BI, the concepts of getting, transforming, and analyzing data are familiar. The difference in Fabric is scale, automation, and governance. These three aspects are covered more robustly in Fabric. So you're no longer preparing data for one report, but you are preparing data for the entire organization. You also get multiple tools to do it, which are pipelines, data flows, notebooks, and your SQL and KQL, each suited to different scenarios. This is the foundation that allows analytics engineers to build robust, reusable, and enterprise grade solutions. So the next section is implement and manage semantic models. So in Fabric, semantic models are more than just Power BI datasets. They serve multiple workloads, including reports, notebooks, and pipelines. So making them a centerpiece of enterprise analytics. So One Lake provides a single lake-centric hub with Delta or Parquet storage. So models can query data without moving it, reducing uh, redundancy and improving performance. So, this approach allows analytics engineers to build governed, reusable data products that power cross workload solutions at scale. So Power BI, for Power BI users, this concept is familiar. The relationships, measures, hierarchies, but now your models are shared, scaled, and integrated across the Fabric ecosystem. So scalability in this context um, refers to building data models that can handle growth within the volume of data. A data model that ingests thousands of rows of data may grow to millions of rows over time, and the model must be designed to accommodate such growth. It's important to consider that your data will grow and change, which increases complexity. So, scalability must be at the forefront in enterprise solutions to ensure flexibility, data growth, and reduced complexity. So, flexibility in terms of models need to be able to accommodate change, and the models must be able to handle an increase in data volume with acceptable report performance, and models built with scalability in mind will be less complex and easier to manage. Now, here, the when designing a scalable semantic model, selecting the appropriate storage model is very crucial. Depending on your data source, you have four options: import, direct query, direct lake, and also a composite model. Each mode has its own advantages and considerations to ensure optimal performance and scalability. So, here you have import model stores data within Power BI and supports all transformations and requires data refreshes in the import mode. And direct query mode connects to data source and only stores metadata in Power BI, and but supports doesn't support all transformations. It supports limited transformations, and also um, but the data stays up to date with the source. Direct lake connects your semantic model directly to delta tables in one lake, and there is no data movement here, no schedule refresh, and then your reports query the lake at speed. Why does direct lake matter? So this eliminates trade-off between freshness of the data and performance. So you get near real-time access with the full DAX surface, unlike direct query, where there is limited support for transformations. So the direct query limits some functionality. If you create the model from desktop, direct lake avoids fallback to a direct query. But if you use SQL endpoints or unsupported features, you might see fallback. So make sure you know your source. And you can pick tables from multiple fabric items, lake houses, warehouses in one model. So this is a huge for enterprise scenarios. And we talked about composite model. So direct lake can coexist with import tables in a composite model. So that means you can mix high speed lake access with curated transform data where needed. So let's look at optimizing semantic models. So in Power BI, you have likely optimized individual data sets for a single report, whereas in Fabric, semantic models can power multiple workloads like reports, notebooks, and pipelines. So optimization becomes critical for scale and performance and also governance. So import mode best practices is you start with import mode whenever possible. Only bring in the data you need, and you clean, aggregate, and shape data as close to the source as possible. And you use star schemas and dimensional modeling for big data, avoiding wide flat tables. Um, and You prepare data for upstream as much as possible. So in Fabric, optimized models are shared across multiple workloads. So each optimization decision impacts more than a single report. So think beyond the single Power BI file. Scale, reuse, and governance guide all modeling decisions. So many best practices from Power BI still apply, but you are now building enterprise grade cross workload semantic models. So you need to connect to views instead of tables when working with relational databases. Include necessary tables, rows and columns only. Use appropriate data types such as integer for ID, columns rather than string, and Also ensure query folding, which reduces the work done with the Power BI engine. Now, the next section is the maintain an analytics solution in Fabric. Here in Power BI, you have used to refreshing data sets and managing a few reports. In Fabric, maintaining an analytics solution becomes much broader because your data models and pipelines can serve multiple workloads across the organization. So this section focuses on two critical areas: implementing security and governance, ensuring the right people have the right access and that your data is protected, and also managing the analytics development lifecycle, managing versioning, deployments, testing, and monitoring so that solutions remain reliable. So the goal is to move from single report maintenance to enterprise grade management, where your work is scalable, repeatable, and governed. So think of it as leveling up from being a report creator to becoming a analytics engineer responsible for enterprise grade data products. So now let's look at data security in Fabric. Security in Fabric is handled mostly at the workspace level, but not entirely. If you are coming from Power BI, this will sound familiar. So you have the managing access mainly through workspace roles and app permissions. In Fabric, security is much broader and more flexible. It's built around several layers that can work together to meet different access needs. The main access controls in Fabric are workspace roles, item permissions, granular or compute permissions, and also one-leg data access controls. So workspace roles, you already know. If you are familiar with Power BI, you can view, edit, or manage items within a workspace. And item permissions are allow you to share individual items like a lake house or a model, or without giving full workspace access to that particular person. And granular or compute permissions is applied within specific engines such as SQL endpoint or semantic model, for more detailed control. And one lake data access control provides file and folder level security directly in the lake using the role based access RBAC control. So it helps to think of these as layers of protection. You start at the workspace level for broader access policies. Then you can then narrow access at the item level, where when workspace roles are too broad. And finally, you can go deeper at the granular level into the compute engines or one lake itself to have more granular control. So together, these layers make it possible to secure data across different Fabric experiences while still giving users the flexibility to collaborate effectively. Next comes security at the semantic model level. So in Fabric, securing data isn't just about permissions, it's about designing your semantic models correctly. So modeling best practices directly impact how well row level and object level security perform at scale. By using dynamic rules, validating relationships, and also keeping your model lean, you are ensuring both stronger security and better performance across all connected workloads. Now that we have covered how to secure your data and models, let's look at how to manage these analytical assets throughout their entire life cycle, from development to deployment to ongoing maintenance. So, as analytics engineers, maintaining the development life cycle means thinking beyond just building data sets or reports. We are managing systems with versioning, um, testing, and monitoring. All these are baked in into these managing systems. So Fabric gives us the tools to work like software engineers. So Um, we have Git for version control, deployment pipelines for promoting content, and monitoring tools for reliability. So, this mindset shift from one off solutions to manage repeatable processes is what truly distinguishes analytics engineers from traditional Power BI developers. So, version control allows you to track and manage changes with Git integration in Fabric workspaces. Deployment pipelines are used for moving content from dev, test, and prod environments with governance and consistency. Testing and validation. You verify data accuracy, model integrity, and security before production. Monitoring using Fabric's inbuilt monitoring usage capacities and capacity tools to ensure performance and reliability. And finally, automation, leverage CI/CD pipelines, APIs, and service principles for repeatable hands-off deployments. Now, the next section is what are the D365 exam prep tips. So first tip is um, leverage familiarity with Azure data engineer concepts. So highlight overlap um, such as pipelines and ingestion processes, but emphasize differences like Fabric's integration with OneLake. Get hands-on. You need to have a hands-on experience with Fabric so that um, you remember when you are trying to um, answer these questions. Okay, you have done this, so that this is the answer, sort of a thing. You can think back when you have hands-on experience with Fabric. So maybe set up a trial environment to explore Fabric's capabilities, and maybe start with a small project like ingesting small sample data, and also create a basic pipeline, and focus on T-SQL skills. So if you are not familiar with T-SQL skills, I suggest you to familiarize yourself with T-SQL skills, which are critical for querying data in Fabric environments. And tip number 4 is use Microsoft Learn modules, which is highly relevant for these specific modules. So you have um, uh, the learn micro the these slides that I've shown you earlier are prepared based on Microsoft Learn sections, the exam sections. So you make sure that you go through the Microsoft Learn modules for DP-600. Um, and also take the practiced assessment. That is what builds you the confidence. You can take practice assessment that is provided by Microsoft Learn, so that you will know where your understandings are. You can take the practice test as many times as possible, and make sure you follow the resources. There are a lot of YouTube resources where you get practice assessment tips and DP-600 tips to prepare. So you can, there is also a link here where DP-600 prepare will give you the link to Microsoft Learn. So you can go through that. And there is also a reactor. So other resources that you can follow is there are Fabric Labs, Microsoft Learn is there, and Reactor DP-600. Sorry, DP-600 series. You can go through those. So if you're not quite ready to sit the exam and want to keep learning, um, you can check out a lot of resources in the in YouTube. Follow Fabric resource, learn Fabric with Phil. That goes through a lot of DP-600 resources, and also Radacad have a lot of DP-600 preparation videos. So good luck for your exam, and that's it from me.